Okay, so today we are doing the systems of equations method number 3, which is solving by using elimination. So let's review the first two systems that are methods that we've already tried, which is graphing and substitution. So if you take your note guide and flip it over to the back, there's two problems that I want you to try. And at this time, go ahead and hit pause on the video and try those problems and hit play when you are ready. Okay, let's go through the systems graphing method. So we have here our y-intercept of positive 4. And our slope is negative 2 over 1. So we're going to go down and to the right and up and to the left. And go ahead and draw in a line for that equation. The second equation is going to start at negative 2 on the y-axis and have a positive slope of 1 over 1. And we notice that these two lines are intersecting here, and that's what we wanted to happen. So the solution for this system of equations is where the two lines meet. And so we always write our answer as an ordered pair when you have two equations. We want to know what value of x and y make this true. So our x value is 2, and our y value is 0. What questions do you guys have over equations, systems of equations? With graphing. Okay. Remember, there are three options. These two equations produced two lines that were intersecting, so that's one solution. It's an ordered pair. If the lines have the same slope, they'd be parallel. Your answer would be no solution. And if these two equations produce the same line, a line graphed on top of itself, you would have infinitely many solutions. So the second method we've looked at was substitution. So ideally in substitution, you have one variable already by itself. And so that's happening in this example. Y is by itself. So we're going to take y's value and plug it in for y. So we're going to take x minus 4 and plug it in. So 4x. And we don't have to have parentheses here because there's no coefficient in front of the y. But I know that we, for the most part, like to write this down. And so then we're plugging in our x minus 4 equals 26. So rewriting this without the parentheses, we're going to go ahead and combine like terms because we did not have to distribute anything. 4x and 1x make 5x. Okay, so they're on the same side of the equation, combine like terms. Subtract 4 from both sides. Do I have any mistakes? Thank you, because that was not going to give me if I subtracted. Thank you. Plus 4 on both sides. 5x equals 30. That's going to work out. Divide both sides by 5, and 30 divided by 5 is 6. So we have our first answer here. Remember, you want to get y. Y is by itself. You can plug into either equation, but it is tremendously easier if you plug back into the top equation. So y equals 6 minus 4, and 6 minus 4 is 2. So our ordered pair is 6, 2. Okay, so that is substitution. Now notice again, one of the variables was by itself. So if we go back up here and look at the steps, flip back over to the front of your note guide, let's look at the steps for elimination. It says mixture of both variables or both equations have variables in the same spot, usually in standard form. So if you look at example 1 and 2, you can see those are in standard form. The x's are in line, the y's are in line. It says rearrange if needed. Okay. Step 2 is also a step that's usually done for you. And it says obtain coefficients for one variable that are opposites. Example, 1 and negative 1, those are opposites. 2 and negative 2, 5 and negative 5, okay? And I'm saying -1, but -1x and -1x. If we need, we'll do a couple examples where we have to multiply by a coefficient to make this method work. And that'll make sense in a moment. We're going to add the equations today. So remember in 3rd and 4th grade when you had to add numbers like 734 and 516, you were adding the columns together? That's what we're going to do with these equations, okay? So think about what you hear when you see elimination. What do you guys think of when you hear elimination? What word? Remove, get rid of, eliminate, right? So when we add these equations, you want one of the variables to eliminate, okay? Is that a question? No? Okay. And then we're going to solve the variable, okay? We're going to add them up, solve, and then we're going to substitute back in. You're going to probably like this method better than substitution, okay? It usually goes much quicker. It's a little bit easier to follow, but it only works if we're ready, like if you have 2 equations in this format. So there's a need for substitution, okay, when a variable's by itself. But if they're lined up, you guys are really going to like elimination better than substitution, I think, okay? So step 1, get the variables in line. All my x's are in line, my y's are in line, my coefficients are in line. So step 1 is done. Step 2 is to add them up. Well, step 2 is, are they ready to cancel, okay? So do we have any opposites ready? We do. We have a -1x and a +1x. So we're going to do this. We're going to go ahead and add these up, okay? So -1 and +1 are going to cancel. 2 plus 6 is, so 8y, and -8 plus -16, -24. That's something that some students forget, is to add these numbers as well, okay? So we're going to divide by 8 on both sides. We're going to keep solving here. And 8 over 8 cancels like we wanted it to. And so -24 divided by +8 is -3. Okay? So we have our first answer. Once we have our answer, it's your job to substitute back in. This time it doesn't matter, okay? One of them will usually be easier for you, but it depends. Every time it changes, okay? It's your choice. Which numbers would you rather work with? The top equation or the bottom? Okay, I heard a couple people say the bottom. There's negatives in both of these. Sometimes students like to prefer to ignore negatives. There's negatives in both. We do just have one negative. So let's go ahead and use this bottom equation to substitute this y value back in. So to do that, we're going to have x plus 6 times a -3 equals -16. So notice exactly what we just did there, okay? We took y and we plugged it back in for y, just like we did on the substitution method. Now you do have to solve this, okay? And reduce. So 6 times -3, -18. And then we would add 18 over. So -16 plus 18 is +2. So our ordered pair answer is 2, -3. Now we just used the bottom equation to get this answer. Let's mentally check this ordered pair in the top one. So if I plug this back into the top, I'll write this down off to the side what this looks like. You have a -x, so it's going to be -2, because this negative sign here, plus 2 times -3. You're asking yourself, does that equal -8? Well, -2 plus -6, yes, that is -8. So we know for sure that that's the right answer, okay? So on example number 2, do you have opposite variables? Are the x's lined up?
Yeah.
Are the y's lined up? If we add right now, will one of them eliminate?
Yes.
I would like you to now try that example. I'm going to give you about 90 seconds here to work, and then I will intervene. All right, you might not be all the way done with example 2. Let's go ahead and see how we're doing, and then I'll give you another one here to try on your own in a couple minutes. So we're ready to add these equations up. 4x and 2x make 6x. My y's eliminate like we wanted them to. And I have 16 plus 8, which is 24. Divide both sides by 6, and x equals 4. So once we have our first answer, we're going to plug in either to the top or the bottom. Any preference? Top. So we're going to have 4 times 4, because we just got that answer for x. Does that say plus 3y since I crossed it out? Equals 16. So 4 times 4 is plus 3y equals, subtract 16 over to get the 3y by itself, so 3y equals 0. Divide both sides by 3, and y equals 0. So my ordered pair here is going to be 4, 0. Let's double check in this equation that we did not use. And if we double check here, it looks like we need to have 2 times 4 minus 3 times 0. So 2 times 4 is 8. Does that equal 8? Yes. Okay. So 4, 0 is the correct answer. All right. So looking at example number 3. Looking at example number 3 and 4, these would both be examples that we're not quite ready to eliminate. So if we look at example 3, we have negative 2x, negative 3y, negative 2x, and positive 5y. We have the coefficients are the same, but they're not opposites of each other. We need one of these to be positive and one of these to be negative. Because this top equation is all negatives, let's get rid of them. Multiply. We need this to be a positive 2. We're going to multiply the whole entire top equation by a negative 1. Okay? By multiplying the whole top equation by negative 1, then this will be a positive 2, and it will eliminate with the other equation. When I multiply, I rewrite it just right down here below, so we're ready to go. So now I'm going to get a positive 2x, a positive 3y, and negative 11 times negative 1 is a positive 11. So I multiplied by negative 1, and what you might prefer to do, like I do, just put a horizontal line right through there, so you know that you're not going to use that equation anymore to finish out the problem. Now that we've multiplied by negative 1, we have obtained opposite. Okay, one's positive and one's negative. Now we're ready to actually eliminate. If you would have added without multiplying by negative 4, you would have got or negative 1. When you added, you would have got negative 4. So now negative 2 and positive 2 eliminate. 5y and 3y make 8y, and 13 plus 11 is 24. Divide both sides by 8, and y now equals 3. You can plug back into either of these equations. I'm going to plug back into this second equation here. Negative 2x plus 5 times 3 equals 13. Five times 3 is 15, getting ready to solve here. I'm going to add, or excuse me, this is a positive 15. We're going to subtract 15 from both sides. So 13 minus 15 is negative 2. Thank you. Divide both sides by negative 2, and x equals positive 1. So the ordered pair that we're looking to see if it's correct is 1, 3. If we take it back into this bottom equation here in red, 2 times 1 is 2. 3 times 3 is 9. 2 plus 9 is indeed 11. So we know this is the right answer. I just want you to look at equation number 4. We're not going to actually take time to do this equation right now, but look at equation number 4. Do you notice that we do both have positive 3y? Okay, those are lined up, but they're both positive. The first step on equation number 4 would indeed be to multiply by a negative 1. So I would multiply by a negative 1 before I got started. If you'd like to try that example and then come back and see how you did, you can. Okay? So if you would, though, flip over to the back. I'd like to take a look at example number 5. Okay? So looking at example number 5. So step 1, are the variables lined up? My x's are together, my y's are together. Yes. Are they opposites of each other? Like same numbers but opposites? Everybody? No. We have a 5 and a 2. They're not the same number. They're both positive. We have a negative 4y and a positive 8y. Are they opposites of each other? Yes, they are. Could we multiply the top equation by something to turn it in to an 8 so it would cancel? 2. So just like on example 3 where we multiplied by a negative 1 to get what we wanted, we can multiply by a positive 2. So if we do that, we could take this whole top equation and we could multiply by a positive 2. And we're multiplying by a positive 2 again to obtain opposite y's. So when we add, they will eliminate. Okay? So distribute this 2 times everything in this parenthesis. So 2 times 5x is 10x. Negative 4 times 2 is negative 8y. And 2 times 3 is 6. Now, don't forget to multiply that last part. That's where some people will make mistakes sometimes, even myself. Okay? And we are ready to add, to eliminate. So we multiplied. I'm going to go ahead again. I'm going to put a horizontal line through this equation because we're not going to use it right now. Okay? So 2 plus 10 make 12x. 8 and negative 8 eliminate like we wanted. And negative 2 plus 6 is 4. And we're going to divide by 12. So what is 4 over 12 reduced to? 3. Close. 1/3. Yep. We do have a fraction here, which is totally fine. So again, this is an example where the elimination would be better than graphing. We could have graphed both of these using intercepts. We would have had some decimals when we were graphing, and then we wouldn't have been able to tell exactly what fraction this was. Okay? So we have our first equation here. This is a x equals 1/3. Let's go ahead and plug that in to this bottom equation here. So it's going to be 2 times 1/3 plus 8y equals negative 2. So 2 times 1/3 is just 2/3 because it's 2 times 1. So 2/3 plus 8y equals negative 2. You're going to subtract the 2/3 over to the other side. If you want to use your calculator, you can. If you want to find common denominators, you can. So what is negative 2 minus 2/3? Those are actually, they're both going to be negative. So negative 2 and 2/3. Okay? Do you want to write that as a improper fraction? So -2 2/3. Okay, if you want to leave it like a mixed number, that's fine, but an improper fraction, that would have been -8/3. 3 times 2 plus 2. So -8/3 is an option there. So you're going to take this number and you're going to divide by 8. So -8/3 divided by 8. -8/3 divided by 8. Should be getting -3. Is that right, Shannon? -3. Oh, that's right, because the 3 is going to flip. So in your calculator, you're dividing that out again. -2 2/3 divided by 8, or -8/3 divided by 8 is going to leave you with -1/3, because those 8s are going to cancel. Okay? And the 3 is going to stay in your denominator. So your answer is going to be 1/3, comma, -1/3. So again, you most likely will not have any fractions on your homework, okay? But this again is showing you that we can get exact answers using algebra. We cannot always get exact answers using the graphing method, okay? And so this was an example showing that we had to multiply by a coefficient to obtain opposite values. At this time, I would like you to try example . We're going to look at example 7. We're going to try example 7, and this will be the last one that we work together. So the unique thing about example 7 is that neither one of the numbers are factors of each other, okay? So I do like that the x's, one's positive and one's negative, and the y's are both positive. Okay, so on the other two examples, we just had to multiply one equation. So this would be the hardest that an elimination problem would ever get, just because you have to multiply two equations on the first step. Okay, so the question you ask yourself is, do you want to turn the x's into, and what would we pick? What's the smallest number that 3 and 4 both go into? 12. So we want to turn those both into 12s, or do you want to turn the y's into 10s? Okay, so that's what most students will say. Well, I'm going to pick what's going to be the smallest numbers. Okay, we do need to make one of these negative, though, if we do that. Whereas the x's were already, one was positive and one was negative. Do we still want to change the y's? Okay, so either way, okay, you could change those to 10s, just make one of them negative. So because this one is positive and one is negative, that's probably what I would do. So I'm going to take this top equation and I'm going to multiply everything by what? 4. Fantastic. And this bottom equation, we're going to multiply everything times 3. So rewrite both equations. I'm going to give you 2 minutes to finish this all the way out, and then I'll show the answers. Okay? Don't forget to multiply the in numbers, like 6 times 4 and 5 times 3. All right, let's go ahead and check and see how we're doing on this problem, and then we'll get started on our homework. So we're going to go ahead and distribute the 4 times everything on top. So say this out loud with me. What are we going to get? And the bottom equation? Okay, we're ready to eliminate. So the x's cancel like we wanted to, and 20 plus 6 is? And 24 plus 15? And we would? And what are we going to get? Okay, and so then we're going to take that answer of 1.5 and plug it back in. I usually pick one of the original ones because the numbers are going to be smaller, but it's fine if you cross them out and you wanted to use a different one. All right, so let's go ahead and try this top equation. So 3x plus 5 times 1.5 equals 6. So 5 times 1.5 is? Subtract 7.5 over, and 3x equals? And what, negative 1.5 divided by 3? Negative what? So negative 1.5 divided by 3. So our ordered pair here is negative 0.5 and positive 1.5. All right, so testing to see if we did that right, let's use this top equation. So 3 times negative 0.5 plus 5 times 1.5, do we get 6? You type that in your calculator and check. And so there is that final answer, okay? If you'd like to try number 8, if you need extra practice, here is what your answers would end up being. Negative 1, comma negative 3. If you'd like to try that on your own, and then make sure that you get those right answers. Okay? All right. That is it.